are places on this planet that don't behave the way they should. Places where the laws of physics seem bent, where life exists in forms that have no right to exist, where scientists have studied the ground, the air, the light for decades, and still have no answer. Most of them you've never heard of. And the last one on this list is the one that concerns researchers the most. Not because it's dangerous, because of what it suggests about everything we think we know. Stay until the end, because the final location doesn't just challenge science, it challenges the story we've been telling about Earth itself. Every year, research teams travel to locations most people will never visit. They carry instruments, they take measurements, they publish findings, and in many cases, they leave with more questions than they arrived with. These are not cursed places. They are not myths. Every location in this documentary is real, studied, documented, and still, in significant ways, unexplained. Some of them produce energy with no clear source. Some grow life that shouldn't be able to grow. Some emit sounds. Some glow. Some simply exist in ways that force geologists, physicists, and biologists to quietly revise what they thought was possible. One of them changes the timeline of what we believed was uniquely human. We begin somewhere that looks like it belongs on another world, but it's here. It's been here for millions of years. And the strangest part isn't what it looks like. It's what lives there. Number 1. Socotra Island. Off the coast of Yemen, in the Arabian Sea, there is an island where the trees bleed. Not metaphorically. When you cut the bark of the dragon blood tree, a thick, dark red liquid pours out. The locals have used it for centuries as medicine, as dye, as ritual. Science has studied its compounds and found properties that are still not fully understood. But the bleeding trees are not the strangest part of Socotra. The strangest part is everything else. Socotra Island is home to over 700 species of plants, birds, and reptiles found nowhere else on Earth. Nowhere. Not on the mainland across the water. Not on nearby islands. Nowhere. Scientists call this level of biological isolation extraordinary. The island broke away from the ancient supercontinent of Gondwana millions of years ago. And in that isolation, life took its own path, completely separate from the rest of the world. The result looks like something from a dream, or a planet that evolved in parallel. But here is the question that still doesn't have a clean answer. Some of Socotra's species show adaptations so specific, so refined, that scientists cannot fully account for how they developed on an island this small, with this climate, in this time frame. Evolution works, but Socotra seems to have worked faster, or differently. The leading theories involve the island's near-total geographic isolation and extreme environmental pressures. But the gaps in that explanation remain open. And one particular tree on Socotra, the cucumber tree, exists in a genus entirely alone. No relatives, no lineage that connects cleanly to anything known. It simply appeared. Evolutionarily speaking, there is an island in the Indian Ocean where life played by rules we haven't finished writing yet. The next location isn't an island, it's underground. And what happened there 2 billion years ago should have been impossible. Number 2. Oklo Natural Nuclear Reactor. In 1972, a French physicist was analyzing uranium ore from a mine in Gabon, West Africa, a place called Oklo. The numbers were wrong. The concentration of a specific uranium isotope, U-235, was lower than it should have been, lower than it is everywhere else on Earth, lower than it is in meteorites, lower than anywhere scientists had ever measured. Something had consumed it. When researchers went back to the rock itself and ran the analysis again, the conclusion was almost unbelievable. The Oklo site had undergone self-sustaining nuclear fission, naturally, without human engineering, without any technology at all. 2 billion years ago, in a seam of uranium ore, groundwater had acted as a moderator, neutrons had collided, and a chain reaction had begun. It ran intermittently for hundreds of thousands of years. The Earth had built its own nuclear reactor. 16 separate reaction zones have been identified at Oklo. The reactions were remarkably stable, cycling on and off as water levels changed, self-regulating in a way that modern reactor engineers study not as history, but as a design model. Here is what still unsettles scientists. The nuclear waste produced at Oklo, the byproducts of 2 billion years of fission, barely moved. The radioactive material stayed almost exactly where the reactions occurred, contained by the surrounding rock. Modern nuclear waste remains one of the most difficult problems in human engineering. We have spent billions trying to design containers, repositories, geological storage systems to do what Oklo's rock did naturally. We have not matched it. The Earth ran a nuclear reactor for hundreds of thousands of years, managed its own waste, and left a record in stone that we only found by accident. What else is written in rock that we haven't found yet? The next location doesn't deal in geology or biology. It deals in light. Light that appears in a valley, night after night, that no instrument has fully explained. Number 3. Hessdalen Valleys. In central Norway, there is a valley called Hessdalen. Since at least the 1930s, and perhaps much longer, residents have reported seeing lights in the sky above the valley, not aircraft, not reflections, slow-moving, luminous objects, some white, some yellow, some red, hovering, drifting, disappearing. In the 1980s, sightings became so frequent that a formal scientific monitoring project was established. It still operates today. Cameras, spectrometers, radar, and magnetometers are trained on that valley continuously. What they have recorded is not in dispute. The lights are real. They appear on camera. They appear on radar. They have been measured and documented by researchers from multiple countries and institutions. What is in dispute is what they are. The leading scientific hypothesis involves a rare form of ionized plasma, essentially a self-luminous body of charged particles that forms naturally in the valley due to a combination of geological, atmospheric, and electromagnetic conditions. The valley sits on a fault line. Certain minerals in the rock are conductive. The interactions between the Earth and the atmosphere above it may, under specific conditions, produce these glowing structures. But that hypothesis does not fully explain the behavior of the lights. Some of the phenomena recorded at Hessdalen move in ways inconsistent with passive plasma drift. Some appear to respond to radar pulses. Some have been observed hovering in place for extended periods before vanishing without dissipating. The researchers are careful. They don't use dramatic language, but the papers they publish in peer-reviewed journals carry a consistent subtext. We are recording something we cannot yet fully model. The Hessdalen lights appear less frequently now than they did decades ago. No one knows why the frequency changed. No one knows what causes the phenomenon precisely enough to predict when it will appear next. A valley in Norway is still being watched every night. Number 4. Tsingy de Bemara. There is a forest in Madagascar that will cut you open if you fall. The Tsingy de Bemaraha is a UNESCO World Heritage Site, covering nearly 1,600 square kilometers. It is made of limestone, but not flat, not layered, not gentle. The rock here has been carved by water and wind into vertical blades. Thousands of them, packed together like the teeth of something ancient. Some rise 15 meters or more. The locals call it the place where one cannot walk barefoot. Scientists call it one of the most challenging terrains on Earth. Nothing should live here. The surface is too sharp, too dry. The channels between the spires are lightless and narrow, and yet, Tsingy de Bemaraha is home to 11 species of lemur, dozens of endemic reptiles, rare bats, and plant species found nowhere else on Earth. They have adapted entirely to this environment, not just surviving in it, thriving in it, moving through it with precision, eating from it, reproducing in it. The limestone itself is the scientific puzzle. The erosion patterns that created these formations require a very specific sequence of geological events: ancient coral reef deposition, sea level changes, particular water chemistry, then millions of years of precise erosion. Researchers studying the site have found that the underground cave systems beneath the Tinggi are still being mapped. What those systems contain, in terms of species, in terms of geological record, is not yet fully known. More unsettling, the rate at which the spires are eroding suggests this landscape is temporary on a geological scale. This forest of knives will eventually be gone. What it contains, we have not yet finished discovering. The next location is quieter. On the surface, it looks simply like a forest, but something about it stops scientists from explaining what they find inside. Number 5. Shirakami-Sanchi Forest. On the border between two prefectures in northern Japan, there is a forest that has not been touched by human hands for 10,000 years. Shirakami-Sanchi is the largest remaining virgin beech forest in East Asia. It spans over 130,000 hectares. It is so ecologically preserved that it was designated a UNESCO World Heritage Site in 1993. The trees here are ancient. The ecosystem is layered. The biodiversity is extraordinary, but it's not the age that interests researchers most. It's the silence. Not acoustic silence. The forest produces sound. What scientists mean when they describe Shirakami-Sanchi as exceptional is that the ecosystem operates with a completeness that is almost impossible to find anywhere else on Earth. Every organism has a role. Every process feeds another. Nothing is missing. Modern ecology is largely the study of broken systems, ecosystems where something has been removed, where balance has been disrupted, where recovery is being measured. Shirakami-Sanchi is one of the only places where scientists can observe an intact reference system, what a forest is supposed to be, what it does when nothing interrupts it. And what they observe continues to revise basic ecological models. The forest stores carbon in patterns that don't match predictions. The water cycle it maintains affects surrounding regions in ways the models underestimated. The fungal networks beneath the soil, the mycorrhizal systems connecting trees over vast distances, are more complex and more communicative than current science can fully map. A forest in Japan is teaching researchers that they didn't fully understand forests. It has been doing this for 10,000 years. Up to this point, each of these locations is strange in a way that science is approaching, slowly, with instruments, with hypotheses. The next places are different, not because they are more remote, not because they are more dangerous, because the phenomenon at the center of each one cannot be physically located, cannot be isolated in a sample, cannot be put under a lens. These are places where the strangeness is not in what you can see, it's in what you can only experience. Number 6. The Taos Hume. In and around the small city of Taos, New Mexico, somewhere between 2 and 4% of residents hear something. A low, persistent hum. It is not constant, it fluctuates. It is more audible indoors than outdoors. It is louder at night. Some people describe it as a diesel engine running somewhere they cannot find. Others describe it as a vibration felt more than heard. Several residents have reported it affecting their sleep, their concentration, their quality of life for years. The disturbing detail is this: standard acoustic equipment pointed at Taos and its surroundings does not consistently detect anything. A formal scientific study was commissioned. Researchers from multiple universities were involved. They analyzed the area extensively. Their conclusion was not a clean answer. The study found that a small percentage of people may be perceiving very low-frequency sound, infrasound, that is at the edge of or below normal human hearing. Possible sources included industrial activity, geological stress, and military installations in the region. But the study could not identify a definitive point of origin, could not confirm a single source, could not explain why some people hear it and others do not when living in the same household. One hypothesis, taken seriously but not confirmed, is that certain individuals may have an unusual sensitivity to very low-frequency vibration, a kind of biological reception that most people don't have. If that is true, these individuals are detecting something real that our instruments are not built to find. The Taoist hum has never been fully explained. It is still being heard. Tonight, the next location is more extreme. It's a fissure in the ocean floor where two tectonic plates pull apart in real time, and where the water itself becomes something else entirely. Number 7. Silfra Fissure. Between the Eurasian tectonic plate and the North American tectonic plate, there is a crack in the earth. It is filled with water. The Silfra Fissure in Iceland is one of the only places on Earth where you can physically place one hand on one continental plate and the other hand on another. The two land masses are moving apart very slowly, a few centimeters per year. Silfra is widening. The water inside it is extraordinary. Glacial meltwater from Langjökull Glacier seeps through a vast underground lava field for up to 100 years before reaching Silfra. During that century underground, the rock filters it, removes particulates. Mineral content drops to almost nothing. The result is water with visibility exceeding 100 meters, possibly the clearest natural water on Earth. Divers enter it and experience something they consistently report as disorienting. Not because of danger, because of what perfect clarity does to human perception. Scale disappears. Distance disappears. The walls of the fissure seem close and then, suddenly, impossibly far. The water is so clear that it stops reading as water. Scientists studying Silfra are not primarily interested in the diving experience. They are studying the fissure because it is an open window into a tectonic process that is usually hidden. The crack is mapped, the widening is measured, the forces pulling the two continents apart are calculated. But the timeline of what happens when a fissure like this widens enough, when the plates shift suddenly rather than gradually, remains one of geology's central unresolved questions. Silfra is not dangerous in itself. It is a measurement, a slow countdown written in rock. The next location is a crater in Siberia, with no explanation for how it formed. And the closer researchers look, the stranger it becomes. Number 8. Patomskiy Crater. In the dense taiga of eastern Siberia, far from any town, surrounded by ancient forest, there is a structure that should not exist. It is a cone of shattered limestone rising roughly 40 meters from the forest floor, with a crater at its top and a small hill rising from the center of that crater. It is approximately 160 meters in diameter. The limestone fragments that form it are not native to the surface. They have been pushed up from below. Local hunters knew about it for generations and refused to approach it. They called it the Fire Eagle Nest. Animals avoided the area around it. The structure was documented by Soviet geologists in 1949. Since then, it has been studied extensively. No meteor impact. The rock shows none of the characteristic signs. No shock metamorphism, no iridium layer, no radial fracture patterns extending outward. No volcanic activity. The regional geology does not support a volcanic origin. The trees immediately surrounding the crater are old, but the trees on the crater's outer edges show a sudden acceleration in growth, a ring pattern that suggests the crater formed, or had a major event, sometime in the mid-1800s. The leading hypothesis, and it remains only a hypothesis, is that the crater was formed by the explosion of underground natural gas, or by the collapse of a subterranean void, or by some interaction between methane deposits and the rock above. But none of these explanations account for all of the features. The central hill inside the crater floor in particular has no clean analog in any known geological process. The animals still don't go near it. The next location is the opposite of ancient. It is one of the newest places on Earth. It appeared in living memory, and it is rewriting the rulebook on how life begins. Number 9. Surtsey Island. In November 1963, fishermen off the coast of Iceland saw smoke rising from the ocean. It was not a fire, it was the birth of an island. For 3.5 years, an underwater volcano erupted, piling lava on top of lava until a new landmass broke the surface and stabilized. By 1967, Surtsey Island was complete. Roughly 2.7 square kilometers of fresh volcanic rock. Barren, sterile, geologically newborn. Scientists immediately recognized what they had: a pristine laboratory, a place where zero life existed, where they could watch from the very beginning how an ecosystem assembles itself. The island was placed under strict protection. Access is limited to researchers only. No contamination from human visitors is permitted. What they witnessed was not what they expected. Life arrived faster than the models predicted. Not much faster, but consistently faster. Seeds came in bird droppings. Insects arrived on wind currents. Bacteria established in rock cracks within years. By the 1980s, mosses and grasses had taken hold. Seabirds colonized, and their waste became fertilizer. Plants followed. Today, Surtsey has over 60 plant species, hundreds of invertebrate species, and is home to nesting seabirds. But the speed of colonization is not the most significant finding. Researchers studying the soil beneath Surtsey's vegetation have found that the island is generating its own biological processes, its own nutrient cycles, its own water retention patterns, at a rate that challenges assumptions about how long ecosystem formation takes. Surtsey is aging faster, biologically, than the models said it should. We are watching life turn rock into soil in real time, and we are still recalculating how long it should take. The final location is different from all of these. It is not a crater, or a fissure, or a forest, or an island. It is a landscape that exists only because of conditions that should cancel each other out. And what it reveals, when you look at it long enough, is not just about that place. It is about the assumptions that underlie almost all of modern science. Number 10. Lençóis, Maranhenses. In northeastern Brazil, there is a desert. It receives too much rain to be classified as a desert by any standard scientific definition. Over 1,600 millimeters of rainfall per year, far beyond the threshold. And yet it looks like a desert. Vast white dunes as far as the eye can see. Almost no vegetation, almost no trees. A landscape that reads, visually, as one of the driest places on Earth. But between the dunes, in the valleys of white sand, there are lagoons, thousands of them. Fresh water, clear, still, bright blue. Some are small, some stretch for hundreds of meters. They fill during the rainy season and gradually recede during the dry months. For a portion of every year, most of them disappear entirely. Then they return. And here is what science is still working to fully explain. When the lagoons return each year, they fill with life. Fish appear, not from any connected waterway. The lagoons have no rivers feeding them, no permanent channels linking them to the sea or to each other. And yet, species of fish that require permanent water to survive somehow persist between cycles. The leading explanation involves fish eggs that survive in dry sand, in a dormant state waiting for water to return. This phenomenon, called diapause, is documented in some species, but the specific biology of how it works at Lençóis Maranhenses, the exact mechanism of survival in that sand, in that heat, across that dry period, has not been fully mapped. Fish are disappearing into sand and returning, year after year. But the deeper unsettling quality of Lençóis Maranhenses is not the fish. The fish are a solvable problem, approaching a solution. The deeper question is the landscape itself. This place should not hold its form. The dunes should either stabilize with vegetation, as they do in most wet environments, or they should move and scatter, as they do in true deserts. The balance of rainfall and drainage and sand composition that creates and maintains Lençóis Maran. Every location in this documentary is actively studied. Teams return to them, equipment is maintained, data is collected, papers are written, and in every case, the conclusion is the same. Not the specific conclusion about that specific place, but the underlying one. The one that isn't always stated in the abstract. We are still learning what this planet is. Not in a modest, incremental way, in a fundamental way. The tools we use to study the Earth, the models, the frameworks, the baselines we measure against, were built using data from a world that was already significantly altered by human presence before systematic study began. We do not have a complete picture of what the Earth looked like before we changed it. We do not have a complete model of what it does when left alone. Shirakami-Sanchi is one of the only places showing us. We do not fully understand how life establishes itself. Surtsey is still teaching us. We do not fully understand what sits beneath our feet. Patomskiy, Oklo, Silfra, still open. We do not understand what the atmosphere does in specific geographic conditions. Hessdalen is still being filmed. And somewhere in the sand of northeastern Brazil, in the dry season, when the lagoons have vanished and the white dunes bake in the heat, something is waiting. It has no water, it has no way to survive, and it will survive anyway, because it has learned something about this planet that we haven't figured out how to ask yet. We call these places anomalies. Maybe that's not what they are. Maybe they are the parts of the Earth that are still telling the truth, and we have not yet learned how to listen.